Hi there, today I'm going to use generative AI tool to get the EBSD analysis data such as grain sizes and phase volume fraction in dual phase alloys. I'm not sure if it's going to work. Generally, you have to use EBSD analysis softwares, which are commercial softwares, and you have to pay for licenses. And if you don't have access, so I'm just trying to see if I can use a public domain available generative AI tool to do so. Let's see how successful it gets. So this is just a fictitious scenario I have created. So let's say from our EBSD data, you can imagine EBSD data can have a large microstructure with loads of grains, their orientation, sizes, etc. And then you analyze the data as an experimentalist to find out what sort of grain orientations are there, what sort of grain sizes are there, if you need any phase mapping, if there are dual phases, then how to do that. You can do texture analysis as well. And for that, you need to use some kind of commercial tools like OIM analysis from EDEX or STEC crystal analysis, Oxford Instruments, or Mambo by Bruker. So there are many softwares. I don't know, their names might have changed by now as well. I'm just thinking over the top of my head and telling you those names. But those softwares are expensive and sometimes you don't have access to that. So for example, in this case, we have a dual phase titanium alloy, which is a combination of alpha and beta phases. So as you can see, these are the scale bars, and this one bar is basically 20 microns or 20 micrometers. And these are 5 of the different images I have selected from the actual EBSD data, where I have plotted the alpha phase as the grayscale. So we are not interested in the alpha phase orientation, but rather we are interested in getting the sizes of alpha phase so that we can use that later on to construct the CPFEM model or crystal plasticity finite element method space model. So these are gray phases are alpha, rest of the grains are beta phases. As you can see, there are some segmentation errors as well. So how we can really use something else than those professional softwares to get the grain sizes, approximate grain sizes, so that we can use those for our finite element based modeling. And also if we can somehow get, let's say, the volume fractions, because when you create an RVE, then you can look at these papers which I'm showing on the screen about RVE analysis, which we have done on aluminium and different types of titanium alloys as well. So in those cases, you need volume fraction of each phase as well. So we will try to see how we can obtain that as well in this video. So enough of chit chat, let's get into it. So what I'm going to do today is I'm going to use this generative AI. You can use any AI tool which you have access to. I'm going to try ChatGPT in this case and see if it works for us. I must say that this is a paid version which I have, but hopefully now, I don't know about the free version right now, but hopefully you are able to upload such images and can do similar analysis there. For free version, there might be limitations of how many prompts you can really provide to get the output which you really want. So let's jump into it and see how it works. So what I will do first, I will just upload this image. This is the ChatGPT 4.0, which is kind of a paid version which I'm using. And I will upload this file, which I told you has those images that I showed you previously on the screen. And now I will ask the question. So say example, I will say I have loaded an image with microstructure of dual phase titanium alloy. I'm not telling which titanium alloy, it's just generic right now. And I will say the gray color is alpha phase, while rest are all beta grains or grains. Can you identify the alpha grains and then measure their sizes? Also, I have provided the scale bar in black color. I'm just trying to be as explanatory as possible. You can start with a simple prompt as well, and then you can refine it. But this will save me some time, so I'm just doing that. I provide the scale bar in black color. I think it was 20 micrometers, which is 20 microns. If it doesn't understand, I'm writing micrometers. Okay, and then I say you are required to get me the alpha grain sizes also volume fraction of alpha phase, because that's what we need for RVE. Because if we know the size of the alpha phase, then we can approximately make the grains, and then around it we can create the matrix of beta phase, and the size of the beta phase will depend on the volume fraction of alpha, because then we will find out, okay, how much volume fraction of beta we can include in the RV analysis. Again, if you're confused by all these things, you can have a look at all those papers which I showed you before. So also volume fraction of alpha phase is needed. So I hope everything is grammatically correct, but it will understand. Let's see how it goes. So anything else I need? No, I think we go with that. Later on, if we have like I will make more videos where I have used AI, these kind of generative AI, to get the grain orientation data as well. But it requires some more work. Also, I will ask him, I think, in this case, because there are multiple grains in some cases. So identify each grain in the images and label them on the images too. So I can also say there are, I don't know how many were there, 6. There are 6 microstructure, which I could have shown on the top as well, which I could have said in the top as well, but let's see. There are 6 microstructures in the figure of photograph, whatever you call it. Let's see what it does. So it is going to do something for us. So you see it says, to proceed with your request, I will analyze the image to identify and measure the alpha grains, calculate their sizes, determine the volume fraction of alpha phase, and this will involve image processing techniques leveraging 20 micron scale bar for accurate measurements. I will also label each identified alpha grain on the image. I will start by processing the image, extracting the alpha and beta phases, and then carry out the necessary measurements and calculations. So please hold on for a moment. Now it has started doing that. It is now identifying the grains, as you can see, and it has identified quite a lot of grains which may not be correct, and it has given us the sizes of the grains as well. So if I click on this image and if I download it, let's say this one, then you can see there are quite a lot of grains it has identified, which is not correct. So at this point, what I find out is, if you use a very big prompt and you haven't tested it before, then this these kind of generative AI, which is in this case ChatGPT, gets confused and it gives you very random sort of results. As you can see, the number of grains it has identified are not correct, and also, I mean, it's going all over the place. So then what I do, I erase its memory, and then again I restart everything, and again see what is the response, and astonishingly or surprisingly, it gives me completely different response if I come back with similar sort of commands. So ultimately what I find out is, if you use a shorter prompt and go step by step, then it is able to give you some more reasonable results. So now I'm going to show you, after spending some time, I would say 1 hour or so, fine tuning the model and using smaller prompts, I was able to get something useful than what we were getting until now. So let's look into that first. Okay, I spent quite a lot of time on fine tuning its response, and then ultimately I was able to get something useful out of it. So that's what I'm going to show you now. So as you can see, I again uploaded the image and I said, here is an image with scale black bar of 20 microns or micrometers. Are you able to give dimensions of gray grains in microstructural images? There are 6 images in the uploaded file. As you can see, it's 4 and 2, 6. So I say I can help analyze. So after a few iterations, it was able to give me this kind of thing. If I can process the image file, I will calculate the grain dimensions in micrometers by using 20 micrometer scale bar as a reference. Let me proceed with the analysis. The image is a PNG format with a size, so it identifies the pixel sizes. To estimate the dimensions of gray grains, I will analyze each of the 6 images in the uploaded file using 20 micrometer scale bar as a reference. I will proceed by locating the scale bars in the pixels to create a pixel to micrometer conversion factor, then measure the grain dimensions. So it has created that scaling factor, and now it will measure the grains. The scale bar labeled 20 micrometers located at the bottom left, and there are 6 microstructural images arranged near the center. I will use the scale bar to establish a pixel to micrometer conversion factor and then proceed to measure the dimensions of gray grains within each microstructural image. Let's proceed with the measurement. the pixel to micrometer conversion factor is approximately this. So again, if you have the image analysis software, you can check this value and find if it's correct. Using this conversion factor, I can measure the approximate dimensions of gray grains in each of the 6 images, and I will proceed with the measurements now. So you can also see in this case the code which it is using in the background, which you can use later on if you want. You can copy the code and create your own Python script. So then the 6 microstructural images are now isolated and labeled using the pixel to micrometer conversion factor. I'll measure the micrometer to this. Let's proceed with the analysis. So it is giving me the step-by-step process it's following. So you can check this and see if everything is consistent. And here you see for all 6 images, it has identified at least 3 grains, and which is based on the gray area. And then it gives you the approximate dimensions. Similarly, then I ask, okay, in each of the images you produce, can you label which you class as the prominent gray grain? Because I wanted to see if it is measuring the right one, and you can see it gives us kind of a response where it's identifying these grains. So this one would be this, maybe this one is this one is this, maybe. So these 3 grains, but again, it can't really label on the figure here, but they are pretty far away. So I say grain 1, grain 2, and grain 3 are not on the image. So then it again tries to do that. It replaces them in different locations, but still it can't really identify or tell us clearly where it is taking as a grain. Also, then I ask, okay, when you say image 1 has this, and this micrometer of grain sizes, what does it mean? So it tells us that there are 3 prominent grains, grain 1, grain 2, and grain 3, and they have these dimensions. Then I said, okay, let's look at only this one first image as well. Let's look at only first image. Can you plot image 1 only with grain numbers and dimensions? So it tries to do that again, grain 1, grain 2, and grain 3, but again, I'm not sure, it's not able to identify which one it is. Similarly, can you create arrows to better link grain numbers with the image, as it is not clear to me which feature in the image are you taking as individual grain? And you can see it creates arrows, it tells us which one is which, but I think it's completely outdated. Most probably this one is 3.3, this one is 4 point this, and this might be 2.5, or maybe the other way around it should be. So again, it's not clear in the image. Then I say, okay, grain 2 and grain 3 are not even on the image. As you can see, grain 2 and grain 3 are not even on the image. So it again tries to plot this, and now it tries to show that which one is grain 1, grain 2, and grain 3. So again, it is struggling to label them on the images. So again, it needs more training and more better prompts, I think. And maybe the picture is not that good as well. As you can see, pretty distorted in many cases. If in image 1, above gray pixels are alpha, while rest of the colors are beta, can you calculate volume fraction of alpha? So now I'm trying to divide the task into smaller groups. I have made kind of a rough measurements, and I can see which grain is which. So this one might be this grain, this one is a smaller grain, so it might be this, and this whole thing might have been taken as a grain, and that's what it's giving us 4.17 micrometer. So then I say use the same scale as before. So I just said everything is the same, just find me the volume fraction. So what softwares normally do, they find out these gray pixels, and then they calculate rest of the other color pixels, and then add them together with total pixels, and then you can find out the volume fraction of alpha will be number of pixels of alpha over the total number of pixels, and that will give you kind of a rough estimate of volume fraction of alpha. So that's what it is telling us what it's going to do. And then it finds out that, okay, in this image, the alpha volume fraction is around 6.17%. I will check that. I haven't checked it, but I will check it with the other software as well, but I don't have time right now. But you can do a check as well if you want with your own microstructure. Can you do the same for the rest of the images, and finally give grain sizes in each image and volume fraction? So now it knows what it has to do, because with one image I trained it how to do it, and I tried to fine tune the prompts and responses. So now I ask it to do for all 6 images in the picture. So that's what it's going to do. It tells us everything, and it gives us the volume fractions and also the grain sizes, prominent grain sizes in each of the images, which are gray grains, alpha cases. So I hope that you found this video useful, and it's kind of helped me as well, because now I have a workflow where I can use this generative AI tool, and I can use it to get the grain size, phase volume fraction information from EBSD images directly. And if I don't have the software, so I can give it to my PhD students or postdocs, and they can save some time, and they can train this ChatGPT model more, because you can in ChatGPT, if you have a paid version, you can have your own custom GPTs, and where you can upload your own data, keep it to yourself, and develop a tool which can work for you in a better way. So that's the idea of this exercise for me. And I hope you also find it useful. You can use these kind of generative AI tools for your own tasks as well this way. And the main story is, if you want to really train them, go with a smaller command, go step by step, and ask it to write the procedure what it's following to give you the outcome, so that you can further enhance the outputs. And obviously you need to know the background theory of that as well. And once you have done that, you can also copy the Python script which is developing as it's moving on, and you can create your own Python script which is kind of independent of what this GPT or generative AI is doing, and you can use that directly on your local machines as well. So if you find it useful, please like and subscribe, and also share it with other people so that they can benefit from it. And if you have any questions, feel free to comment below, and I will try to answer as soon as possible. So good luck with your learning journey, and I hope to see you in some more interesting videos in near future. All the best.